this is the development of the parrotfish seamate. So we have here the hardware. So we have the ESP32, which is our main microcontroller that can be programmed in MicroPython. And this is our GPS receiver, which is connected to an external antenna. And if you can see, the light is blinking. That means there's a lock. And of course, our LCD, where our visual data is displayed. So I'm going to show you through the screenshots of our MicroPython session in VS Code. So this is the terminal now, and these are the different files that I generated. Particularly, the files that are most important is the GPS display only py. We also have the IL9222325py. So this is the 92225py is actually the library for the LCD displays. So for example, if you want to display text, you set the orientation. So every functions or every function is stipulated into a certain class. So here we're going to define TFT12IL2925 class, which will inherit which will become our LCD object. And along that object, they have a lot of functions like write or methods, write CMD, write data, and so on and so forth. So this file defines all the methods for our LCD objects. Another one is we have the NemeaPy. So this is actually a class that will parse the GPS sentences. And through this Nemea, we can then call our GPS display only py. Here we have the initialization routine, okay, wherein we import our Nemea library, our LCD ILI925A, and among other libraries, and we initialize the latitude and latitude of the system, and we initialize the hardware, and we have the different functions like beep, which will beep, and draw beastmap, show splash. So these are the different functions that can be called in the GPS display routine. So I want you to go to this portion here wherein we have two while loops, while 1 and another while loops based on the if statement. So if I press one switch, this will be executed when this is true, but if this is false, this will be executed. So this differentiates or divides the code into two parts. One is in the here, if the switch is pressed, we're going to go to mode 1, wherein the display is a map data, map interface with the latitude and longitude, and of course XY coordinates, and of course the marker. And if we're going to press the switch at the bottom, we're going to have the mode 2 in the main routine, wherein you're going to have the textual displays. So right now it's running. So now let's try to run the code and download the code in the microcontroller. First thing you have to do is connect to the device. So it will say connected successfully, and it will now go to the REPL prompt. So we'll have to wait a while. So this is now the REPL. We are now connected to the microcontroller in VS Code. So what we're going to do is right click this main py, GPS display only py, and click this run directly on the device. So here, this will run the system on the device, or this prompt. It will first a flash screen, then we go to mode 1, and it will indicate the latitude and longitude and the XY coordinate, and also our marker. So it runs now. So okay. Now we can actually stop that. Control C. Okay, and then reset the system. And then let's try to go to mode 2. So in mode 2, what we're going to do is we press this button, which is at the bottom, which is the switch mode, okay, to go to mode 2. So we're going to run that again. So once that's prompt, we press it, and we now go to mode 2, wherein we have textual data. And then we can long press this switch, okay, to initiate the initial position. So it will mark our initial position. So when we move, the distance from origin will now change. So definitely we are now 0. Okay, so since we don't move. Now when we move, this will change. Okay, so this is the session, and also in the prompt you can see the data like the time, the latitude and longitude, and the number of satellites being displayed. So we are now locked, and if you can see, the GPS module is blinking, so that means there are 9 satellites, and we have accurate data for the satellite system. So our GPS is accurate. Now let's stop that. One option is, how do we generate the map? So to generate the map, we need to have a map. So the maps that I have is this one, and also this one. So where did I get this? So basically this will be parsed by the microcontroller. This is stored in the microcontroller, and that is actually parsed by the GPS display only. Okay, so in this routine, no? Particularly in draw base map and draw marker. So in the draw base map, we open the map files, the array map files, which is generated from the bitmap file. Now how do we get my map 1 maps, like map 1 and map 3? So there are a lot of methods you can do this. You can use the idea from one of the session that we have, that we are in the other days. He created a session on how to generate geolocated maps from OpenStreetMaps and so on. But for the sake of introduction, so this is not yet the most rudimentary method. So my method is quite crude. So what I do is, to generate this map, I go to the OpenStreetMap here, and then I try to press, like say for example, I want to get this portion, the portion of where I'm operating, which is in Cagayan de Oro. Let's say here in Canituan. I'm here in this portion, which is in Canituan there. So what I do is, I go to export. Okay, and then if you notice, we have a boundary box. So this is the latitude and longitude bound. Okay, latitude bounds and longitude bounds. So we have a square portion. So I manually select an area. Okay, so like that. So from Canituan, let's say like that. So I make sure that this should be 220 by 176 pixels, and I take note of these boundaries. So this bounds 125.576. This is the longitude for this, and this one is for the longitude for this. This one is this one, and this one is this one. So this is the bounding box. So I take note of this, and then I will feed it to the program later on. So once I have that, I could get export, but what I do is simply copy, get a screenshot. So I'll print screen, and then I go to the paint program, and then what I say is just paste. And from there, I do a crop. Okay, so I select this portion, and then crop. So once I have that, I can then save that as, okay, I can say a bitmap file, no? So let's say this is our map 4.pmp. Okay, so I make that as a bitmap and save it. Okay, so once I have that, it is now saved. We now have the we choose another utility, which is image to LCD. Here we open that bitmap. So our map is actually map 4. Okay, there it is. Open. So once I have that, this one will convert it to a 16-bit 3-color RGB pixel, and it will convert that also into an array. Okay, so I choose 16-bit color, and I can adjust the output. So this is the initial image, and this is the outputted image, and it will be saved as an array. So we save this as say array.mp, so which is a binary file. Save that. So this will save it as an array, a binary array, and from that I can now open it in VS Code. and then I can upload that. So and I can put that in my workspace. Okay, sorry. So there, I can import file folder, and that is map 4, right? Or actually that's array. There was that. Marker, map 3. So anyway, so a good example is maybe this one, no? So I open that, and from there, this is the map file. So I can actually show the hex dump. So this is now the array of our image, and this is the one this is now the array portion of the bitmap image taken from the LCD image to LCD utility. And from here, if you look at the display only in the draw base map, we open that particular file. So for example, map 3, this is the generated array from a map bitmap. I read that and store it in array, and then draw that to the LCD image twice. So that's why we have a display. So for example, Control D, let's generate it again, run code. Okay, so there you go. So this is the generated bitmap coming from the array. Okay, so good morning. So we're going to test the Parrotfish seamate using land-based system. So we are not at the sea at this time, so we are running through a car, and the system will be tested, and then you can see the latitude and longitude of the Parrotfish seamate. So what we're going to simulate is that you can see in the screen the latitude and longitude and the X and Y of the marker. So the idea here is when we run through that area, our marker should be able to change as we run through across this map. So if you can see, the map is land through our area. So the notion is once we run and change our position, the marker should also change position, and an indicative of the change in latitude and the XY coordinates of the marker should change as we go along. So now we're going to focus on mode 1, wherein the display is the map interface. So here's the map. So we're going to move now, and you will notice that the marker will change, and the X and Y coordinates of the marker will change, as well as the present position, which is longitude and latitude. So we're moving now. Okay. So now we have stopped, and if you look at the display of Pycon, so the marker has changed. So we have now changed from our previous position. So at this point in time, we're going to try the mode 2. In mode 2, the display of the seamate is not a map but textual data. So I'm going to change to mode 2. So what I'm going to do is press this button, which is our button B, and then try to restart the system. And then the system restarts, and keep on pressing. So we are now in mode 2. Okay, so these are the various datas, the latitude and longitude, the FMA, of course, the distance from our origin. So we reset our origins to 0, and this is the distance from the city hall. Okay, and the other data, the number of satellites is 11, and this is the atomic time, okay, from the GPS. So now we're going to move, and let's check if the value changes. So we're going to go back to our initial position. So now as we move, you'll be able to see the display changing. So our latitude and longitude changes, and also the distance from our origin should now change. So the distance from the origin is in kilometers. So more or less we must have traversed around 100 meters so far. So this is mode 2. So there are two modes. Again, mode 1 here is the map interface and the latitude and longitude plus the marker. And in mode 2 we have textual data being displayed. Okay, so that's it. And that's it for our land-based trial. So we are now in around more or less 12.86 kilometers from our origin. This is just to test the functionality of the sea parrot seamate. Here you can see that it will give you coordinates, if you could see it, and it's quite dark, right? And from there you can see the latitude and longitude, as well as the FMA where you are. We are at FMA 9, and then the LGU is El Salvador, and then also from there you can see the distances, the distance from origin and the distance from the municipality city hall, which is LGU. So the reading is around 12.85 from our origin, and from the city we have 15.26. So we are actually 15.26 kilometers from the city hall of LGU, of the El Salvador LGU. Sea wardens are within municipal waters, and they have the exact location. The exact location also is being transmitted via this transmitter, via LoRa. So my location is now being transmitted to the relay at the shore, the one at the buoy, and then retransmitted to a base station. So we can actually track our traversal in terms of position. So that's how our system works. So technologies we use is MicroPython. Of course, in the website, my other partner is developing it in Flask. Okay. So for my portion, this is the MicroPython, and my partner, Ace Marcella, is involved in the Flask development and the website.